This is a continuation of our intermediate linear programming problem where we are going to add a couple slightly more complicated constraints to see how those are set up. We already have the solutions from the problem in here, so you may wish to review that video if you want to see where those came from. The types of constraints that we have here is that one of our variables has to be bigger than another, and that is not something we have done before. So for this constraint, we want the number of newspaper advertisements to be greater than the number of radio advertisements. And recall we have two different types of radio advertisements, 30-second and 1-minute radio advertisements. When we want one variable to be bigger than another, what we are going to do is indicate the larger thing with a positive number and indicate the things we want to be smaller with negative numbers. So in this case, we want newspaper to be bigger and the radio to be smaller. We are going to copy down our sum product, and I will explain this in a second, but it's easier to set up first and then explain when it's already there. We want this to be bigger than or equal to 0. Okay, here's why this works. If we take a larger value and we subtract a smaller value, we will get something that's bigger than 0. So since we want newspapers to be the larger thing, we're going to take the number of newspaper ads, subtract the number of radio ads, and if newspapers are bigger than radio, we will end up with something bigger than 0. Another good way to see what's going on here is to notice that that constraint is currently not met. Negative 1.2 is not bigger than 0, and the reason for that is that newspaper ads are not currently more than radio ads. We have 5 newspaper ads and 6.2 radio ads, so our constraint is not met by a difference of 1.2. So it's always thing you want to be larger, positive numbers, thing you want to be smaller, negative numbers. This is a similar constraint, except that we're working with costs and we've added a 2 in here. So we want the dollars spent on newspaper advertisements to be the larger thing. If you recall, we figured out the amount spent on newspapers by taking the cost for one of them, which is $9.25, and using our sum product to multiply it by the 5. So right now, $46.25, the amount spent on newspapers. We want that to be bigger than 2 times the amount spent on television. Since the television is the thing we want to be smaller here, we're going to indicate that with a negative, and 2 times the cost of a TV ad is $1,600. Again, we want that to be bigger than or equal to 0 because that's how we set up constraints where we want one variable to be bigger than another. To help see what's going on here, you'll notice that this constraint is met. 1475 is greater than or equal to 0. That's because currently we are spending more on newspapers than 2 times the amount spent on television. So since we do have a constraint that is not met, we are going to run solver. Since we've previously run solver on this problem, the beginning of this is already set up. We just need to add one more constraint, and that is that these values have to be bigger than or equal to these values. Click OK, tell it to solve, tell it to keep that solution, and we'll notice that these values have in fact changed. We used to have more radio advertisements than newspaper advertisements. We added a constraint that newspaper advertisements had to be at least as much as the radio advertisements, and now they are. 5 at least as much as 5. We noticed that the TV had to change as well in order to compensate for the lost radio over here. And so our new solution, 2.4 television advertisements, which we'd probably round to 2, 5 newspaper advertisements, 5 30-second radio advertisements, and no 1-minute radio advertisements.